Hey, welcome back to Common Sense OT Security. Today we are going to do a deep dive into the technical domain of prioritizing OT vulnerabilities. And to put it in very simple terms, why is that a thing? The answer is quite simple, because you will have to deal with hundreds of thousands of vulnerabilities unless you are working in a mine power shop. So for the mid-size and large manufacturing companies, as an example, or also in the process industries, it's not about several thousand, it's about several 100,000 vulnerabilities. And certainly you cannot patch them all at once. You'll also never be able to patch them all. And therefore you need to apply some judgment here, what you want to focus on first in the interest of risk reduction. So, I mean, this is not a new topic. Obviously, there were several approaches in the past, and some of them I have discussed already on this channel. The prevailing wisdom for prioritization is that you use a three-tier categorization, where you say, okay, we have these vulnerabilities that you must remediate now. And then you have those that are in the next category, and you have a third category that you label never. Where simply based on your analysis that you have done, you have arrived at the conclusion: no, these really don't affect us. We don't need to worry about them. We will not remediate them. We just decide to live with them, to accept the risk. And this usually applies to CVEs with a severity rating of low, sometimes even medium. And just as a reminder, then you also have those ratings of high and critical. So what's the problem with this three-tier approach? Well, basically it's an illusion. If you think this would work in real life, you're just fooling yourself. And it's easy to see why. So let's just say your vulnerability as analyst has determined there is this new critical vulnerability that affects, I don't know, a particular firmware version in our drives or PLCs. It's critical and we must remediate it now. Okay, so what do you think is going to happen? You tell the engineers in the field, you have to update the firmware right away, like until end of this day. It's not going to happen, because in order to install that new firmware, you need to power down the process. So you need an outage. It doesn't work anywhere else, in any other way. And your engineers and operations will just tell you to go F yourself, because they need to have the plant up and running. So in other words, the idea that this vulnerability is so critical, we must remediate it right now, that's not working in real life, and just for practical reasons. Another good example would be all your outdated operating system versions, your Windows 7 installations. Let's just say just another new critical vulnerability for Windows 7 pops up. What do you think is going to happen? You're going to need at least a year to replace the Windows 7 operating system. All that planning that is involved, and all the testing, do all the applications that are critical for our operations, are they still available for new operating system versions? So that won't happen overnight. In other words, your now basically is diluted. It's an illusion that cannot be executed in real life, because it does not factor in the practicalities and all the constraints that you need to worry about when it comes to configuration change. And a similar thing happens with Next, because so the problem with Next is Next can also mean in 2 years, when I'm done with all that other stuff. And if you think I'm joking, no, actually that is, I'm quite serious here, because you should not forget one thing: new vulnerabilities pop up every single day. So what you have categorized as next today might be shoved down the queue tomorrow. So that's not really practical. What I want to show you today is a more practical approach that we have implemented in the OT-based OT asset management system, which also does vulnerability and exposure management. And before I go into the details, I just want to briefly set the stage here for those who are not super familiar with vulnerabilities and vulnerability management. So, and if you look at this table here, this is the CVE table in OT-base, and it shows you all the CVEs that affect our installed base here, and only those. So there is a total of, I don't know, 250,000 CVEs overall since the beginning of time, and you will only see the CVEs that actually affect your installed base, not with a particular probability or likelihood. No, they affect your installed base. Seriously. Why do I point this out? Because you will probably have seen it in OT threat detection products that they attach a probability and likelihood to CVEs for given devices, and that's just nonsense. So that is something that you can just kick into the trash can right away, because you will have to deal with so many vulnerabilities that the idea to first start your whole analysis with figuring out if the CVE is even real for your environment, you will never get anywhere. So let's have a closer look at one of these CVEs here. If you open it in OT-base, so you get this vulnerability profile, and then you see the affected devices down here. Okay, so it affects 136 devices. This Rockwell vulnerability, that's about factory truck service platform. And since OT-base knows for sure where you have those products installed, it will tell you right away where the affected devices are with certainty. And one other thing that's important to point out here, in OT-base, you will never do a vulnerability scan. That doesn't happen in OT-base, because a vulnerability is always associated with a particular product version. Just to give you an idea how that looks like in the NVD, in the National Vulnerability Database. So here is the CVE description of the CVE we have just looked at. And if you scroll down, you see the known affected configurations, okay? That is called the CPE here. And by using this identifier, if you have an OT asset inventory, in this case, recording all the installed software products, you know right away where the affected devices are. And this is what OT-base tells you without any probabilities and likelihood. So that is just made up nonsense. And the root cause is that the threat detection products cannot reliably identify the products that you have installed, the configurations. So it's not about the CVE, it's all about the product. So it all starts with the asset inventory. If you have an accurate and detailed asset inventory, there are no probabilities and likelihoods. So this is how that works. And then you have this list of vulnerabilities that affect you. And in our example here, I've already limited it down to anything relating to Rockwell, just to make it more appealing to our audience. And then, as you know, you have all these CVE characteristics, some of which are hidden in this vector here, in the CVSS vector. Then you have the base score, and then you have the severity, okay? And all those characteristics are certainly also exposed here, and OT-base will also tell you, well, this affects the software product as an example, whereas other CVEs might affect hardware products and firmware. And why do we expose this? Well, very simple. If it's a hardware or firmware issue, you know right away you will need downtime for remediation. So just, just slap your now criticality or whatever you want to call it. They must remediate it now. You slap that on, but it doesn't have any effect, because the guys in maintenance and engineering, they cannot update the hardware or the firmware right now. Okay, they will have to wait until the next outage. So this is what is exposed here, and this is about the CVEs. Now, the one mistake that most users make here is they focus on criteria that are not really helpful when it comes to OT. And the best example is the severity. So the severity column lists the various severities as assigned by MITRE for those CVEs. And you see it's high, critical, might be also medium and low. And you will also, again, find this in the CVE description that you see here. And that is not really useful for OT for several reasons. So one of them is that just as an example, so the severity rating uses things like with the impact on confidentiality, which is usually something that we don't really worry about in OT. That rating must not be useful for OT. Just to give you another example, you only have a critical severity starting with CVSS version 3. And all the older vulnerabilities don't have a criticality rating, even though they might have a CVSS base score of 10. Doesn't get any worse than 10, but you will find old vulnerabilities with a severity rate, base score of 10 or anywhere between 9 and 10 that are classified as high severity because they're old. Because back in the days, like in 2012, critical severity didn't exist. So that's not a good idea to rely on the severity. And therefore, in OT base, we have introduced an additional field, which we call priority, that you see here. Okay, so for any CVE that you can open here, it exposes the priority. And here is how that works in principle. The priority is if you don't change anything, and just hear me out, bear with me. The priority defaults to the severity by default. And then you can change it to express a different assessment. So you could manually change the priority to another value that might be higher or lower than the severity. So if you click on edit, here you see that option, and it's grayed out here, and you will understand why in a couple of minutes. But usually, so in the default configuration, you could manually set the priority to any other value. It's copied from the severity, but you can overwrite it, okay? And that would be a good approach to arrive at a more meaningful assessment of the CVE for your environment. And the reason why in real life it doesn't work so well if you do it manually, because you would have to do that for several thousand CVEs. So as you know, I've filtered already for Rockwell. If I remove that filter, then I'm looking at several thousand CVEs. And I won't be able, so like 14,000, almost 15,000 CVEs. I won't be able to do that manually for all those 15,000 because I only have so much time. So therefore, automation is needed. And that brings us to maybe the most important basic insight when it comes to OT vulnerability management. The major tasks that you need to accomplish must be automated, otherwise you won't go anywhere because of the sheer numbers. You know, it's so much data that you cannot process it manually any longer. That doesn't make sense. So that brings us to the question: how would we / should we manually make that setting? So first of all, is that supported in the product somehow? The simple answer is yes. You can set that priority field depending on or according to your assessment, basically in two different ways. First, you can use the REST API and then write a Python script and just change those values based on your criteria, which are usually expressed in the form of rules. I will show you what that means in a couple of minutes. And the second option is OTBase can do all of that for you automatically from the start if you choose the appropriate configuration option. So if you go to settings, metadata, and product data CVE priority, here you see, oh, I have to share the screen, excuse me. So in the administration area, you can set the CVE priority field either to automatic or manually. So here we have set it to automatically, and then OTBase will automatically adjust that setting based on a couple of rules that we are diving into right now. So to give you an idea, this is a Python script that will allow you to override that priority field. And the rules that we have built in for this automatic adjustment follow the logic that you see here. So it's basically, it loads all the CVEs from OTBase inventory, which is very simple, as you see here. So this one, these two lines here, they do the trick, right? So they load all the CVEs and then store the result in a JSON object. And then next loop here, so we loop through all the CVEs and call a transfer function F. And there we determine the new priority. And you see this function F right here. So let me just talk you through the logic here. It starts with determining if there is a known exploit for that CVE. If yes, we set it to critical no matter what. No matter what else comes, we just say, no, known exploit, this is critical. Then the next logic is, if the base score is 9 or higher, then we also set it to critical. Then if the attack complexity, so the complexity that an attacker would need to accomplish in order to exploit this vulnerability, then we upgrade the priority one step if it isn't critical already. That's an upgrade. If the vulnerability can be exploited via remote network access, then we also upgraded it one step. And finally, if I need local access to exploit the vulnerability, like physical access, which is all of these items are part of the CVE description, okay? And if local physical access is required, then we downgrade it by 2 steps. Okay, so this is the logic that we use for this automatic adjustment of the priority field. And if you think, no, that's BS, they had a very bad idea, well, just change the logic to whatever you think is better, whatever yields better results for you. And based on that, then you arrive at these fields right here that you see in the first column, and they may/will be different from what you see in the severity field. Okay. So for example, here you have a couple of criticals, and the color coding tells me right away, that is in MITRE's mindset, this is not a critical critical CVE. And just to give you an idea, what you see here is this particular one. It can be exploited remotely via the network, and the attack complexity is low. Okay, so that will give you an idea how this assessment was made. Good. And then you have a more realistic rating of those various CVEs. Now, certainly, the CVEs alone, they are not nearly halfway. So you're just starting. That's a complex topic. When we speak about vulnerabilities, that is not the same as CVEs. The CVE is the problem in a product. However, that problem will affect many devices. You can actually see how many in this column right here. So it ranges from 300 something down to just a few. Okay, and all of these devices may have very different characteristics, and certainly those characteristics may be very important. So you might arrive at the conclusion, well, for this particular device, this vulnerability is much more important than for those other devices. Just as an example, depending on the device's network exposure, if you have one and the same problem, like let's just say an issue with your operating system version that is outdated, or an application that is bug-ridden, then it makes a huge difference if that application or software in general sits somewhere down in a process network where it's very well shielded by network security, or if it sits on top, like in the DMZ or in the enterprise network, who knows, right? So that makes a big difference. And that is something that you will want to factor in. So in other words, when we are talking about individual vulnerabilities, now we are talking about a combination of CVE that we have discussed already, and the properties of an individual device that is affected by the CVE. That's a big difference, right? And we must put both aspects together to arrive at a proper assessment of that vulnerability. And this is what you see here is like the vulnerabilities table in our TBS, where you can see right away, just by looking at the color codes, how these two aspects come together. So in these first left-hand columns, you see everything that is associated with the CVE. And then in the right columns, you can resort that in any way you want. This is just how I have sorted it for this presentation. And in the right area, you see all those properties of an individual device, like the name of the device, the category. So in this case, we are looking at actuators here in those first lines, right? The vendor, the model, the criticality of the device, the network exposure, the target security level, if you have set one, the purview level of that device, the risk score. And I'll get to that. So bear with me, the risk score is like the magic number that we will get to later. So bottom line, we need to combine both these two aspects to prioritize the vulnerabilities. We are no longer talking about the CVEs. Now we are talking about the individual vulnerabilities. Okay, and let's see what this entails. So what you see here is a conceptual breakdown of those various parameters that we can bring into play here. So on the left side, so the overall box, so this black box here, that's the vulnerability with all its components. And that vulnerability is basically defined by these two aspects, two sides. So in orange here, you see everything related to the CVE. And in blue, you see everything related to the device, the individual device. And we must bring that together. So what we have done already regarding the vulnerability, the CVE, is we have talked about the base core, the attack complexity that we get from the CVE definition or description. We have talked about the attack vector, also part of the CVE profile, and the KEV, which simply means is there a known exploit for the CVE or not. This is unfortunately not contained in the CVE description. We have to fetch that from CISA, but OT-based does this automatically from you, consolidates everything. And as you have seen already, now we can put all of that together and compute a resulting value, which we call priority. So this gives us an idea about the badness of the CVE for our environment. So we can assess, well, what do you see? And I promise you, in many cases, you will say, oh, no, that's irrelevant for us. And in OT-based, you don't have a never category for vulnerabilities or CVEs. You can just flag a CVE as irrelevant, either in total or for individual devices. And then I won't care about this anymore. So here is where you compute the priority, and that does not necessarily involve an arithmetic computation. It can also be rule-based, as I have shown you earlier. And then let's look at the device properties. Now, you could start with the target security level according to IEC 62443 if you wanted to. That's a field that is available in OT-base. In our experience, well, let me put it this way: I don't like it very much because, per the definition, it makes a couple of assumptions that don't make a lot of sense to me. Those assumptions have to do with the attacker's capabilities. Like, do I have to worry about a nation-state sponsored attacker? Then that must be the target security level must be full. Okay, and honestly, I don't know what to make out of that. Maybe it gets even easier when you look at the bottom security level 0. Like, no security settings are required. Guys, are you serious? I mean, that would mean I can just put my stuff on the internet and stop worrying and live my life. Certainly, that's not how it works. So, bottom line, if you are an IEC 62443 fan, you can use the target security levels. They are available for every single device. And certainly you could incorporate that in your computation of the risk score. So this is where this bottom box right here, this is what we suggest to do. We suggest to compute a risk score for every individual vulnerability. And that could be derived from your target security level. If you're using security levels, it most likely will use the target security level. By the way, looking at the clock, so we will go into overtime. This is such a complex field. I cannot compress this into 30 minutes. Then, as the next box here, we have the network exposure, which obviously is very important. That means, does this particular device, so we're just talking about devices here in that blue box, does this communicate with other devices in adjacent private networks, as an example, as opposed to does it only talk to devices within the same local subnet? And then certainly another probability or possibility would be, is it exposed to the public internet? The public exposure. If it is, then that will certainly affect your risk score for obvious reasons. Okay. Now, the good news is that OT-base can tell you automatically if you're using the host-based alternative versions of OT-based discovery, which I suggest you download for free from our website, OT-based discovery agent and OT-based mobile discovery. They will tell you right away. Network exposure is public, as an example. You see all the orange data flow. So that is very simple to collect, at least as long as we are talking about Windows boxes and Linux machines. And that will have an influence on your risk score. Then we have the criticality of the device. So apparently some devices are more critical than others. The damage when those devices are compromised might be much higher than other devices, and therefore you will apply criticality ratings to your systems and devices, and based on the criticality you will arrive at a different risk score. And OT-based makes this very simple because it allows you to slap a criticality rating on a system, which would be something like a machine line, or a support system, a vacuum or ice water that is required by multiple processes. And once that you do that, all the devices that are part of this particular system, they inherit your risks, your criticality rating. So then bam, you can use it in your computations and rules right away. And finally, you could also use the network zone. Let's just say you are, again, an IEC 62443 aficionado. You think that's a very useful concept. Oh, no problem. You can express your zoning in OT-base. You can slap it on a network, and then again the devices inherit this zone value. So that is also something that you can work with. And then you will put it all together to arrive at this risk score. And if you ask me, I would not suggest to use risk scores such as now, next, and never, because that's not good enough, right? So just keep in mind, you will be faced with hundreds of thousands of vulnerabilities until you're operating a small sewage plant in Podunk, Idaho. I mean, nothing against those guys in Podunk, Idaho. But I'm just saying, if you're operating anything of size, so we are talking about hundreds of thousands of vulnerabilities, this is just the nature of the OT vulnerability game, because we have to deal with outdated operating system versions, we have to deal with outdated firmware, and all these aspects have us or produce this exorbitant number of vulnerabilities. That's just a fact of life. So now let's go back to our vulnerability table, where we again we could manually record our risk score. Right, so we have determined, we say this is 90, and this is what I would suggest. Use a numeric scale to your liking. Some of our customers say, oh, that makes sense. We're going to use a scale of 1 to 100 or 0 to 100. Others say, no, it's 0 to 10. And then there is also somebody who says, well, I'm using 0 to 25. To me, I would probably expect 42 would be a more more appropriate value for IT guys. But anyhow, so you can encounter everything in real life. And therefore, this is not predefined by OT-base. You use whatever scale you like. I just suggest that you use a numerical scale. Because if you have to do something about these, in our case here in our sample database, roughly 900,000 vulnerabilities, I mean, what does it give you if you end up with 120,000 that have the rating now? It gives you nothing. You will just put the whole thing away in frustration. What do you think is going to happen when you present that result to your management? Well, you 120,000 that should be remediated right now, like till end of day. They will laugh at you, best case. Worst case, they will just assume you're incompetent. So that numeric scale works better. And again, you cannot operate on this manually. You will never get anywhere. And therefore, in OT-base, you can again do it using a script. And tell you an example. Show you this example, how such a script could look like. Again, we are using the REST API here. The REST API allows us not just to access the CVEs, but also the individual vulnerabilities. How cool is that? And that is our angle to compute and set the risk score automatically. And I hope that one thing stands out here when you look at this script, or this is the full script. We are talking about 47 lines, including comment. So it's not really a big computational effort that needs to be done. So we are loading a couple of devices here that we are interested in, and then we go through these devices, and then we set the risk score for these devices for a specific CVE. And this is our main loop down here. It looks similar like what you have seen in the other script. Then we call our transfer function f, which now looks a little bit different because the output values are numeric. And we use different parameters. So we use the CVE priority. That's what I've shown you in the first part in that CVE script. And then we use, in our simplified example here, we use two properties from the device. We use the criticality and the network exposure of the device. And so based on that input, we say, well, if the CVE priority of that vulnerability is critical, we set a risk score of 50. If priority is high, we set it to 30. For medium, we set it to 20, and if it's low, we set it to 5. Now, if there is a criticality for that device, then we double the risk score. And certainly here you could go much more granular in OT base. Not only you can express a range of criticalities, like from 1 to 10 or something. You can also express the quality or the nature of the criticality. So, for example, you could say, well, if it's safety critical, I would treat it differently than if it's critical for business continuity or something, okay? So you will get those values in this loop, and you could use it for your processing logic. Then another rule, if the exposure of that particular device is public, meaning it is exposed to the public internet, and we see that if we have the data flow, we know right away, oh, this is internet traffic. Then we set the risk score to 100. So this is a very simplified logic that gives you a starting point on how to compute and set those priorities. And certainly you will most likely want to go further. You want to expand that logic. And then once that you have done that, your risk scores will contain some values. So when I now sort this table based on risk score, you see something like this. So now you see something like this. So here we have the risk score starting with 50, and I think maybe what should strike you as well. There are actually a couple of vulnerabilities here with quite a considerably low CVSS base score, such as 5, but our logic has bumped up the risk score for depending on the rules that we're using, okay? And so that will give you an idea how that works in real life. And then you will be able to select vulnerabilities that you sign up for remediation based on the risk source, or based on, let's just say, the urgency of the vulnerability, and also based on additional criteria. Because here is another thing that many people forget when it comes to meaningful remediation. So remember, I told you already, well, you cannot patch firmware overnight. So it requires outage. It requires planned outage. And even if you have that planned outage, the engineers on site may still tell you, no. In that outage window, in that maintenance window, no, we cannot do your fancy firmware updates. We just don't have time scheduled for that. So that might happen. But in other words, when it comes to remediation, you always have to factor in the practicalities of the matter. And that usually begins with the question, can this remediation be done remotely? Or as another example, is that something that the network team can do, from HQ? They just make a couple of configuration changes in the firewalls or in the routers. That's awesome. Or does it have to be done by local staff? Like the local engineers and maintenance specialists. And therefore, another very important aspect is when you consider turning this into remediation tasks, which in DBase you're only a couple of clicks away, you would usually, once that you have made your selection here, so you could say, well, let's just start with anything that is categorized as 50. So now, no, I'm only talking about 7,000 and change vulnerabilities, okay? And then I could filter it further down. And one way to do that when it comes to remediation is to also factor in the localities. So you get the locations right here. I could say, no, I'm just starting in the USA in that Flatrock plant, okay? And they're probably only looking at specific network types, my friends. This is something that is embedded in DBase. Not only do you see all the individual networks, and you can also assign network types, like this is a safety network, okay? And once that I do nothing in the safety network. So that's the good news. However, if I use another network type like real time, also nothing. So I have 2,000 in my Flatrock plant in non-real-time IO networks, okay? And then I could either filter it further down or turn this into a remediation task for the guys at Flatrock with a couple of mouse clicks. So this is how we get from the assessment to the prioritization and then to the remediation. And once that you then have turned it into a remediation task, you can also set a timeline. You can define your expected date when it all should be finished, and then it's going to show up. You will see how many devices are left, how many vulnerabilities, etc. Unfortunately, this example doesn't look too good because the deadline is long in the past. Okay, but I think you get the gist of it. And this is how I suggest to do prioritization of vulnerabilities. So we have a couple of comments or questions. Let's see what we got. So we have our friend Gary. This is like QuickBooks taking away the math in accounting. Absolutely correct. Thank you for pointing that out. Then what else do we have? What about asset-based vulnerability management, where you use risk of asset using some criteria like it's really? I think this is answered already in the meantime. So just for those who joined the stream later, in the first part, I have talked about CVEs, but that is not good enough, right? So the CVEs are not the vulnerabilities. The vulnerabilities is where a CVE affects a specific device. And that is where you bring in the device properties, such as the criticality. So that's a super important point. If you only rate the CVEs, that's not going to give you much, because your result set will be much too big. You will still be talking about hundreds of thousands of vulnerabilities, and you must crunch these down, because otherwise you will never arrive any success in remediation, because you can only do so much. That is basically what it all boils down to. I mean, just consider if remediation would be free, no resources would be required. We wouldn't have this problem because every single organization would make sure that all of their vulnerabilities are remediated. But that's not the case. OT, vulnerability management or exposure management, if you can also call it, because you're also factoring in the criticalities, etc., is very, very expensive. They're completely different from IT. And therefore, you will never have the resources to remediate at scale. And this is where the prioritization comes in, where you must prioritize. But why? Because you don't want to waste your few resources that you have, right? So you want to still arrive at meaningful results. What do I mean by that? Results that clearly, where you can clearly demonstrate, okay, our attack surface now has gone smaller. That is what you want to report to management with facts, and that is what we help you to do. See you in a week. Bye-bye.